Hey, welcome to the numbers game. I'm Coach T, and in this tutorial, we'll be using derivatives to find the center of mass. Let's get started. In this tutorial, we'll be finding the center of mass of an object. So what is the center of mass? Well, given some object, the center of mass is the average position of all of the parts that make up that object. And that's what this is. The average position is represented by average of x and average of y, and this is the point that represents the center of mass. So how do we find this point? Now, the center of mass is made up of m sub y over m and m sub x over m, where m sub y represents a moment of y and m sub x represents a moment of x, and the m in our denominator represents our total mass. So we're given an example that says, find the center of mass of a thin plate of constant density dell covering the region between y equals 1 over the square root of x and the x-axis from x equals 1 to x equals 4. Now, before we start solving this example, let's go over a few formulas. The first formula we'll take a look at is the formula for total mass. And that's going to equal our integral from alpha to beta of our function with respect to x. Our next formula is m sub x, and that will equal the integral from alpha to beta of a half time our function f of x squared with respect to x. The last formula we'll need is m sub y, which equals the integral from alpha to beta of x time our function with respect to x. Now we have everything we need to begin to find the center of mass. We'll start by calculating the total mass represented by m. We'll solve the integral from alpha to beta. In this example, that is 1 to 4. And we're solving the integral of our function given by 1 over the square root of x with respect to x. Let's rewrite 1 over the square root of x as x raised to negative half. And solving the integral, we'll get 2x raised to a half, or otherwise we can rewrite this as 2 square root of x, and we'll evaluate from 1 to 4. Plugging in our bounds, we get 2 square root of 4 minus 2 square root of 1, which leaves us with 4 minus 2, giving us a final answer of 2. So here we found that our total mass equals 2. Now I'll write our total mass over here for us to remember and erase the board to make space. We'll move on to finding m sub x, which is given by the integral from 1 to 4 of a half time our original function, which is 1 over the square root of x squared. We'll start by moving the constant to the outside of the integral, so moving the half to the outside, replacing our bounds, And we'll also get the square root of x out of the denominator, rewriting it as x raised to the negative half, and this is being squared. From here, we're left with 1 over 2 of our integral from 1 to 4 of x raised to negative 1 dx, which can be rewritten as half times our integral from 1 to 4 of 1 over x dx. This leaves us with a half ln of x from 1 to 4. Plugging in our bounds, we get a half time ln of 4 minus ln of 1. Ln of 1 reduces to 0, leaving us with ln of 4 over 2. So we were able to find our m sub x, which equals ln of 4 over 2. Alrighty, now let's move on to finding our final part, that is m sub y. As we've discussed before, m sub y equals the integral from 1 to 4 of x times our given function, 1 over the square root of x, and we are integrating with respect to x. All right, now let's start with rewriting our 1 over the square root of x, which gives us x raised to the negative 1/2 dx. And now x times x gives us x raised to a half, because we just added the exponents 1 plus a negative half. From here, we see that our integral equals 2x raised to 3 over 2 over 3 from 1 to 4. Substituting in, we get 2 times 4 raised to 3/2 over 3 minus 2 times 1 raised to 3/2 over 3. With a little bit of algebra, we see that we're left with 2 times 8 over 3 minus 2 over 3, giving us a final answer of 14 over 3 for our m sub y. All right, now let's see what all this gives us for our final center of mass. Our center of mass is given by m sub y over m and m sub x over m. Plugging in, we get 14 over 3 over 2 and ln of 4 over 2 over 2. Using our fraction rules, we can simplify this to 14 over 6 and ln of 4 over 4. So we multiply 3 times 2, giving us a denominator of 6, and 2 times 2, giving us a denominator of 4. So this is how we find the center of mass of a thin plate with a constant density of dell. If this video was helpful, give it a thumbs up and subscribe to the channel for more math tutorials. Thanks for watching The Numbers Game.